In this video, we are going to continue our discussion of non-right triangle scaling or oblique triangles. There are going to be cases where we could potentially have more than one triangle, and I'm going to explain why. When this happens, we call this ambiguous because we don't know if it's one or the other. So in these problems, if there are two possible triangles, you're going to have to find the information for both. So let me describe the scenario. So we are given ASS, angle side side. The angle that we're given is right there. We have an alpha, and then we're given this side. So the way I want you to think about this is think about this as like a long board, maybe wood, and we're creating some kind of ramp, right? To walk up, skateboarding, I don't know, right? Some kind of ramp. Whoever decided this decided, hey, this is the angle that's appropriate for this. And then also it can't be longer than B. And then they're like, here's your third piece to create your ramp a. And that ramp, what we're trying to decide is, can we build a ramp from what's given? So for instance, if they gave me this alpha and that beta and A is too short and it doesn't hit the ground here, then I don't have a triangle, right? That would be, I have this ramp, it's got to have that angle, it goes all the way up there, but the extra piece of wood that I have to create that balance is not long enough. So no triangle. Now we have a right triangle if we set up that angle, right, that alpha is the same and that beta is the same, but that piece of wood that is like we're going to try to build our support with, it actually goes down to the ground to actually support what we're trying to do. So it actually creates a right triangle. Give me one sec. I got to plug my charger in. I meant to do that before recording. All right. So again, it's like us creating a ramp, and it's having that extra piece of wood that's either going to dangle or it's going to actually hit the ground. So if it hits the ground directly, right, and it's a perfect fit, it's going to cause this right angle here. We have a right triangle. This happens when this A, this extra side, is equal to the height of that triangle. That's what we're really looking for. So A is less than H. That's what they mean by here. It's not as tall as the height there. H is the distance all the way down, if you haven't put it together. So A is smaller than that height. Here, A is the same. And then this is our ambiguous case. So imagine we have our alpha. So the same scenario, they give us this alpha, they give us this giant plank of wood. And they're like, okay, that's your ramp length. It can't be shorter or longer. The alpha has to stay the same, but we have this piece of wood. All right. This piece of wood this time that's we're going to try to build our support with is actually bigger than the straight down. So it won't fit, right? If you try to put it straight down, it would lift this up or it would have to be bent in some way. So what that means is we could like, okay, the A comes down to here maybe, like too far. Well, I could just like rotate it over both ways and get my new triangle. So I could just put a triangle there and then there's one triangle. Or I could do a triangle here and get this triangle. Right, so I have two possible choices, and how I tell from this is completely based on A. If A is bigger than H, then we get two triangles. Now, this is the weird thing. That A has to be smaller than the ramp given, right? If the support is longer than if this is longer than the ramp given, then this thing is definitely not going to be able to make two triangles because once it swings out, like what we're saying earlier, is this swings out to that, right? I get two triangles by swinging out that one piece that stays the same. But if that piece is longer than B, that means when I swing it over, it's not going to hit the ground until I get over here, right? Think about it. If H is here and it's longer, A is longer than that B, and I swing it over, well, if it was B, that's where I'd get my triangle and it'd be a right triangle. But here is all, it wouldn't be a triangle at all, actually. But if it goes past it, it's going to be out here creating one triangle. So if A is shorter than B, we get two. If this A is longer than B or the same size, we get one triangle. That's it. All right. So here's my technique. I'm gonna write it out because I don't like to use what they're doing with memorizing A and all that. So find H, which is the height of the triangle, right? Is A equal to H? If that's the case, right triangle, right? is A less than H? If it's less than H, then no triangle. All right, those are our H. And now our last two would be if A is bigger than H. All right, and we get two scenarios potentially. All right, if A is bigger than B, one triangle. Remember, that's like our dangling support where A's are trying to hit the ground with our ramp. It's bigger than B and it's going to swing around. We talked about that doing something. Oops, that's not a line. Doing something, if it came straight down, then I would swing it and it'd go outside the triangle. So if A is less than B, then we have two triangles. Oops, there we go. All right. So it's this took me a while. If I'm being transparent with you, it also taken me a while. Like, a couple times I fell flat on my face in class. I've been teaching like this is my 11th into my 11th year. But this stuff's hard to remember. So give yourself some grace while you're learning it. All right, so here's an example. So let's figure out how many triangles we have first. So to do that, I'm gonna go over here and do the right triangle case. So the right triangle case would be that same setup, except for we're going to go ahead and find the right triangle. It's like right there. That works. It's good enough, right? Okay, so there's it's horrible. There's my right triangle. This is 35 degrees. This is 8, and this is six, not 6. We're given 6. I want to find H. So this is our how we find H, which is the right triangle case. So we always start there because if H is equal to 6 or H is less than 6, we're done. There's no triangle, or we can just go, we have a right triangle, we find the third side and the third angle. Okay, so let's find H. So that's going to be sine of 35 degrees. We're using sine because we have H over 8, which means H is equal to 8 times sine of 35 degrees. So I'm going to go ahead and type that in. So 8 sine 35 degrees. Okay, it's about a 4.6 if I round pretty hard. So what that means, the side that was given to us to create this ramp was 6. Now, do not use your eyes. I don't want you to look at that and be like, oh, well, that's not straight down. They might not do that. They may just draw a random triangle and put it. Usually these triangles are not drawn to scale. All right, so we had about a, what did I have? 4 points, was it 5? 4.6. Okay. I don't know how I got erased. 4.6. Okay. So what that tells me, since 6 is bigger than 4.6, this line here, okay, if it was 4.6, it'd be straight down. So this distance right here is 4.6, all straight down. So since this 6, okay, and then this is where we start thinking about it. Okay, that means I'm going to have, since it's bigger than H, I have two triangles. So the question is, can I do this with both sides where that's 6 and this is 6? Does that work? Or is it going to be one of those things where I can get it to be out here? Hold on, let me straighten that up. I can get it to be out here, but the only other way is to go way out here because it's bigger than 8. All right, well, 6 is not bigger than 8. So that means I do get the two triangles that look like this. All right, so I'm going to go ahead and set this up, alpha, and I'm going to do alpha 1, beta 1, gamma 1, sub 1, a sub 1, b sub 1, c sub 1. The reason I'm using ones is because we're going to have alpha sub 2, beta sub 2, gamma sub 2, a sub 2. Oops, put some space in there. Go ahead and call this up. All right. And then I have a sub 2, b sub 2, c sub 2. Okay. So I know I'm going to have that. Whatever was given is the same. So 35 degrees, I'm going to put a line here so I don't mess that up. 35 degrees there. This is also 35 degrees. We also know little a has to stay 6 and stay 6. And then little b, we don't have anything. Oh, little b stays the same. It's going to be 8 and 8. Now what's going to change is b. And if you notice, b is going to change if I move beta, not b, sorry. If I move beta around, it changes gamma's angle and gamma side, because gamma side is c right here. And it also changes beta, obviously. If I change beta, beta changes. All right. So that's why I have those three spaces and two different spots. Okay. So the first thing that we're going to have to do is try to figure out B1. And how we're going to do that is we actually just set it up. This calls for law of sines because I have two angles and one side. But we're going to have to do it differently here because it's going to spit something else out. All right. So what we're going to have is when I use law of sines, I get sine of 35 degrees over 6 equals sine of beta 1 over 8. If I solve for that, I get beta. Oh, we're going to have a little bit more here. This is changing it just a bit. We get sine beta equals 8 times sine 35 degrees. We should have a 6 out here, by the way. 6 times sine beta 1 equals 8 times sine 35. So that means sine of beta 1 is going to be, and I'm not even going to reduce because we don't have to. I'm going to plug it in a calculator. I get sine of 35 degrees. Make sure you're putting that degree symbol over 6. All right. So I'm going to do 8 sine 35 divided by 6. All right. Oops, I never put 6. There we go. So there's my answer. And I'm not going to do anything with it yet. I know that beta is going to be inverse sine of all that. I'm going to cheat there. Okay, well, that's approximately, okay, if I do that and take the inverse sine of the decimal I just got, I got 49.9. So this is 49.9 degrees. All right, so I know that if this 49 degrees, 49.9 degrees, I can also find gamma 1 by just subtracting. So 180 minus 35 minus, and I'm going to go ahead and use 49.9 since I rounded, 95.1. So this is 95.1. Right? And then we can do law of sines one more time here to find our last one. So I'm going to use the 35 and the 6. And then I'm going to use sine of 95.1 degrees over little c1. This is going to work out like what we've been doing in the last video. C1 is going to be, okay, look at your cross multiplication. I get 6 times sine of 95.1 degrees. And it's going to be divided by 35, sine of 35 degrees. All right, so let's plug that in. Sine of 6, or 6 sine of 95.1. Enter. I guess I could do it all at once, but I get nervous about it. Oh, and I divided the wrong number. So that number divided by sine of 35. There we go. So I got roughly about a 10.4. If I go back up, that makes sense with my angles and everything, right? So here's one answer. It makes sense. Like 10.4 goes with the biggest angle. That's what I'm saying makes sense. Now, how I find this is this angle's going to change a bit because they gave me beta. I know beta here, right? Beta is this angle right here. What I'm looking for now is so we have that angle. What would this angle be then? So we have to start thinking about it. Now, this is a 6 as well. So let me go ahead and show you the triangle that we're working with. I have this triangle right here. Now, notice, since both are 6, those two are the same. This gives me a triangle, it's called an isosceles triangle. And what that means is that this angle there is the same as that angle there. So as long as I can find the side, this angle there, then I have it. Well, look, this makes 180. Right? The blue one and the pink one. So how we find this angle is we just take 180 and we minus beta 1. So beta 2 is going to be 180 minus beta 1. So if I did beta 1 minus 49 point, that'd be 130. 130.1. I think yep, that works. All right, so now this opens up for the second triangle. If it didn't work, where you know how we had to determine if we had two triangles or one triangle, if 6 was bigger than 8, if that was the case, this would be messed up. It wouldn't work. So if you look here, if I add those two, I get 165.1, 14.9, I believe. Let's double check that. It's in the morning for me. So we got 180 minus 35 minus 130.1, 14.9. Okay, cool. And then the only way to find the last side, can't use Pythagorean theorem, it's not a right triangle, but I can use law of sines again. So sine of 35 degrees over 6, I can use that same one. And then now I have sine of 14.9 degrees over C2. So cross multiply and divide, we get 6 times sine of 14.9 degrees over sine of 35 degrees. If you need to show the step in between, please do. All right, so that means C2. I need this to open. I get 6 sine of 14.9 divided by sine of 35, and we get about a 2.7. That makes sense if we look at our angles. That one is corresponding to the 14.9, which is pretty small. The big angle is 131, and that gave me an 8. And then the middle angle, 35 degrees, spit out a 6. It makes about, it looks like it would make sense. This is hard. Give yourself grace. There's a lot going on. The whole determining how many triangles. I like to call these problems tutor killers because it's such a niche case that most of your tutors that have been through these courses are going to have a hard time remembering this. So if you go get help, what you should bring your tutor is this stuff right here. All right. So take those notes, remind them, and they should be able to help you. All right. 2 more examples on this one. So I'm going to go ahead and figure out how many triangles we have before I write out my grids. All right. So I have, I'm going to go ahead and draw it the way I'm used to seeing it. This is what I like to see. I like to see this angle here. So 85 degrees. And then what they give me, that's not 185, 85 degrees. The side next to it's going to be a 9, and then the dangly piece is going to be a 12. So first thing first, the right triangle. So let's find H. That's what we're doing here. All right, so if I do a right triangle, best right triangle I can, probably could do better, but it's okay. And I got 85 here degrees and a 9, and we want to find this H. So that's going to be sine of 85 degrees equals H over 9. If I solve for H, I'm just multiplying both sides by 9. I get that. So let's figure out what H is. All right, so H is going to be 9 sine 85. So I got an 8.9. So definitely 12. That's what they were given. That thing, the distance from here to here, right? I'm trying to draw it to the side of it. That's going to be 8.9. So this 12 is going to be like way past it, right? Now our question is from here, I know it's not a right triangle, okay? And there is a triangle for sure because 12 is bigger than 8.9. If it's smaller, then it would be, like I said, a dangling piece of wood that does no support. So we have that. So 12 is bigger than 8.9, and right, 12 is bigger than 9, which is that other side. So what that means is this side out here, when I move it around, like I can't make 2 triangles here. I can't put a side right here and a side right there this time. It's not going to work because this 8, the 12, it being 12, it's not going to land in here. It's going to land out here. And then the other one's going to be like way out here. But since that's going to be over there, we're going to have to try the same triangle. Because if I move, like think about this, if I were to move, those 2 lines. So let me draw 2 straight long line there. Okay, if I go this way and go past it, like I've been saying, the problem here is this creates a whole new brand new triangle to begin with, right? We no longer even have the 85 degrees. It would get rid of it. So the only thing that would make sense here, if it's longer than that 9, is to go way out here and create that triangle. So we know that there is one triangle because 12 is bigger than 9. So that implies, that's what this double arrow means, one triangle. I'm always kind of happy when it's only one or none. None's the best case. All right, so one triangle. So I got an alpha, and I'm going to do ones now. Alpha, beta, gamma. And A, B, C. I know alpha is 85 degrees. And then what else do we have? We have drew all over it over here, but right. So, oh, we probably should label everything because it's kind of confusing. So between 12 and 9, that's alpha. That means the 85 degree, that's a gamma. And then this is beta. Okay. That makes that a little better. So 85 is not A. 85 is gamma. My bad. All right. So we have that. That's why I had to go back and relabel. Let's go after, what do we have? So we have across from C is 12. We also have across from beta is 9. This sets it up perfect for law of sines. I got sine of 85 degrees over 12. So just be careful with the labeling and turning your triangles over and stuff like that. Just make sure to be accurate. Sine of beta over 9. Just like in the previous problems, I'm going to cross multiply. So I get sine of beta equals, I'm going to do this one little intermediate step here because it's a little different. 9 times sine of 85. And then that 12 would have went with the sine, so I'm going to put a 12 underneath. Or with the beta, I mean. And then I know that once I plug that in, I'm going to do inverse sine of that to get a number. All right, so let's do that. So inverse, I'll do this one all at once, I guess. 9 times sine of 85 divided by 12. So I got about a roughly a 48-degree angle for beta, 48 degrees. That finds alpha then, because what's that, 120, 133, so 47, I believe. Right? So if I'm looking at this, I expect this number to be pretty close to 9. Because those angles are pretty close together. Okay, remember I can't find I can't use Pythagorean theorem, so I'm going to do another law of sines. I'm going to fit it in right here. Sine of 85 degrees over 12 is equal to sine of 47 degrees over A. So A then is equal to 12 sine of 47 degrees over sine of 85 degrees, whatever that may be. 12 sine of 47 divided by sine of 85. I got roughly about an 8.8. So our guess was right. It's be close to that 9 because the angles are the same. All right, there's our answer. The reason I also like to do that grid there, all my alpha, beta, gamma, and ABC is because my answer is all in one spot. I also am I am very bad at finding one part of a problem and moving on. Meaning I would have found this beginning beta and I'm like, oh, we're done. I found my answer. Well, when I do stuff like this, I typically see it and I don't move on. All right, I got one more example for this video. Find all possible triangles if one side has an opposite angle of length 4 opposite of an angle 50 degrees and a second side length as 10. So I'm gonna try to set it up in that same picture. Some kind of triangle. I don't know that bottom, but I know this is 50 degrees. And then they said the side across from that opposite. So this is a 4, and then this is a length 10. All right, so first things first, let's figure out how many triangles. So I'm going to do the right triangle case. Every time, that's where I start. Here's my triangle. All right, and I got 50 degrees, and I got a 10, and I'm trying to find H. All right, so find right triangle. I should put those words in there. Find right triangle, H. All right, so H then, or let's set it up, sine of 50 degrees is equal to H over 10. So that means H is equal to 10 times sine of 50 degrees. All right, so we get 10 sine of 50, and I got a 7.6. All right, so I know that the height is 7.6. What we just found was this height from here to here is 7.6. So what this means is that 4 there is not even going to reach the ground to support the ramp. So I like these problems the best because we are done. No triangle. All right, so those are the cases. Give yourself grace. They take practice, I promise. I would recommend not just writing down the rules on the top. I would recommend thinking about what I was saying about creating that like ramp and why it would make sense to take the route that you're taking. Otherwise, you're memorizing a recipe, and recipes are not great. They're called algorithms in math, but algorithms are not great because, yeah, they're great to figure it out in the moment, but if you don't do it for a long time, you're not going to remember the algorithm, meaning that you need to like think this out. Okay.